great architectures, one thing in common. They're simple. Here is the Roman aqueduct. And do you know what was the one job it had to do? It was supposed to bring water from outside the city to the city, right? And do you know one rule, like one, maybe not engineering, but one physics rule that was used to make it work? Gravity, yeah. It uses gravity. It's simple, it lasts, and it's very recognizable. And the word simple will be with us throughout this talk. It comes from Latin, how it can be, simplex, which means one fold, and this is the opposite of complex, which is folded together, and there are many things folded together. My name is Grzegorz Rożniecki. Thanks for introducing me. You can call me Greg. I'm a senior engineering manager at Akamai, and today we'll talk about DevOps, platform engineering, Talos and Omni. So for me, the journey started 2 years ago when I thought that I have to speed up with the technology because my company bought Linode and now it's a public cloud and my team started building platforms. And I thought to myself, okay, I'm building a house, so I will have a home lab. And this is how I imagined it would look like. Obviously an AI-generated image. And this is how it looks like right now because 2 years later, we still haven't finished. Finally, we have a place to live, and in our flat there is this small home lab that I have been using for basically learning Linux and Kubernetes. Linux I knew. So I thought, Kubernetes, how hard can it be, right? So I started with like normal, okay, Google something and choose Proxmox and then maybe K3s. But I told myself, okay, I have to have some kind of another tool, maybe for storage, okay? So I used TrueNAS, and for my VMs, I tried to figure out, okay, maybe Ubuntu. Oh no, if you were on the railway talk, you know that immutable OS is great. Like, I will do my own immutable OS, right? And this will make my life easier. So I can use Kairos, right? And then maybe IAC, so Terraform, I will add to my home lab so that it's, one click and it will be deployed. Oh, maybe I will use Kubadm because, this is the right way to deploy Kubernetes, right? Or maybe Ansible is the way. Ansible, so maybe there is this kube spray. And I think that you see where is it going here. It's like it was much, much, much too complex for me as a hobbyist to set up a working Kubernetes cluster. And it's even before you go to the CNCF landscape. It's the old, by the way, this is very old. Right now it's more than 2000, I believe. And it's like on purpose, it's not readable. And there is this note at the top, if you see, overwhelmed, please see CNCF trail map. It should be easy, right? But as a hobbyist, I was stumbled. And I think that in our industry, many, many people and many teams do stumble in these troubles as well. It's always like this. We will build this the right way, but it always ends up like this, right? So I look at all of this and I try to find a solution. And that's why that's how I found Talos Linux. This is, we are at TalosCon, so obviously this is how Talos solved my problems, but why it solves more problems, I think I would like to share it with you, because it's simple. Like, this is the common slide that is shown, I would say, by the CDO folks, because it shows what's the upside of having this simplicity built in. There is no SSH, so there is no problem. Obviously, there were some SSH vulnerabilities some time ago. So this was like a good response to, okay, there is a CB, there is no problem. But I would add to this slide a bit more. Obviously, this is just an API OS, which means that everything that you do, use API. And this is the way in the 2020s, you always have APIs for the cloud, so why not for iOS? For me, it was very weird at the beginning, but it looks like it's the best way to approach the simple assumption. I just want to have a Kubernetes installed, period. I don't need anything else. Because there is no SSH and just an API, there are no users. So no problem in terms of like user management, password management. Simple. No shell, again, no shell shocks, no vulnerabilities at all. It's immutable and it has fewer than 50 binaries, which makes it very, very simple. Like, the one job that Talos is doing well is to deploy Kubernetes on top of it. And this is yet another example of a good architecture that lasts. And this architecture actually brings me to another topic, the abstractions. And do you know that good architecture is the abstraction that just simply works. This is the quote from Grzegorz. He has written a few books on architecture, and I think it's a good also parallel between what we are trying to do here. So this is Pyramid of Giza, obviously, and these are built from little bricks, like Lego, but 6 tons, so little bricks. And you can see that this is the architecture that lasts. It's very, very simple, but it's also like composable. If you think about even Lego brick, you can compose big things that last just using the simple abstractions, right? And I also learned that abstractions and standards help you, and they help you manage some things. Like in homelab, for example, I, at the beginning, didn't know why people are so obsessed with these racks. There are some standards and whatever. And despite, I built my homelab and I showed you the photo, the backend usually is very messy, right? So it looks more like this. You don't see this often, you don't show it often, but this is the problem that we have in our industry, right? So it seems that everything is so simple at glance, but if you are starting to do the things from scratch, like I tried with my homelab, and like some companies do, like the French railway, for example, it gets very, very messy very, very quickly, right? For me as a hobbyist, my main constraint was time. Obviously, I don't have time to dive in rat holes and try to see how, for example, use the cabling best. This is hardware side, right? So I didn't want to mess with that. This is okay, right? But from the software perspective, by choosing Talos Linux, what I got in return was just a working OS for the thing that I want to do. I want to just use it for Kubernetes workloads. And going back to the pyramids of Giza parallel, this is like a typical architecture, and it's also in form of architecture. But I would like to warn you that this is not the right way to build good architecture, good platforms nowadays. It should more look like this, because good architectures, good platforms should abstract away things that you don't want to deal with. And this is the bottom part, like the complex stack. Here, it's like how to set up Kubernetes. It's abstracted away. It's a good foundation. And you have a few unified interfaces. In terms of Talos Linux, obviously, it's an API. And with APIs, there is also, you can have an extension. That are a few built-in extensions, right? And you can write your own ones. And this makes you interact with the underlying layer, on a way that you want to do if it's necessary. But 80% of time, you shouldn't be doing that. And then on top of it, you can do anything. Like, again, Talos is a perfect example because it's a vanilla Kubernetes at the end of the day on this Linux OS that allows you and your teams to do anything that you want. And this talk will not be about this layer on top because you saw the landscape, right? It's very, very diverse. You can do all of that because the interfaces don't restrict you. And there is this book that I read some time ago. It was recommended to me by my boss. It's a novel, actually. I'm not sure. Do you know this book, The Phoenix Project? Oh, many people do. So it's about a guy who finds himself in a situation that he leads a whole IT organization. And it's like 10 plus years ago, and it was quite normal that Dev and Ops are separate organizations, and there is this wall, the friction between, right, that separates them and makes them, Dev and Ops, work like they were not working in the same team, literally and figuratively. And the term DevOps, which was the answer, was coined in 2009 by Patrick Dubois, and so this is like 16 years ago, so not that long ago, it seems. But the point was to tear down the wall between Dev and Ops and to make work of developers easier. And it was because they were sort of stopped and slowed down by the traditional cycle of the siloed approaches in the organizations, right? And the Phoenix Project, the book, is like tells the story of this IT executive who finds himself in trying to discuss and wiggle away with some very tight timelines and different teams working on different priorities. And this is how I think the DevOps should be looked like. If you look at this book and in general, it's aligned with this even agile approach that very, very broad terms like DevOps and agile. But in my opinion, this is not like what specifically should be done. This is not about the tooling per se, but it's about mindset, right? To tear down the walls. And this actually has a consequence, because if you now have DevOps team, it seems that everybody in the team has to know everything. And this brings another problem, which is cognitive load. So the answer to this is obviously that you have to focus. And by my home lab, for example, I chose to focus on the layer on top of Talos. I'm talking about about Talos today, but it was very easy for me to start working on learning Kubernetes, right? Because this is the perfect abstraction that allows me to focus on the things that I want to focus. And whether it's like my home lab or your production environment, this is the point. You should choose your battles wisely. Like if you want to deal with kubeadmin, then that's fine. You may have the perfect adventure for a few months if you want to make it scale up. If you want to use cluster API, for example, you also may try to do that. I think some companies tried and failed. I believe that even Sidero tried and sort of switched the gear here. So you have to choose some battles that you want to focus on. And again, I told about the cognitive load, which is a term used for if there is too much stuff on somebody on a team, then you are not making things easier and life simple, right? So complexity actually is the opposite of our simplicity that I mentioned in the beginning. Complexity, in my opinion, is the hidden tax of modern architectures. And what can we do to focus on what's important? Just a quick poll here. So bare metal versus virtual machines. Which camp are you in? Like, do you prefer bare metal machines, show of hands, or virtualization? Virtuals, okay, 50-50, it's very, very close. What's really, really important from my perspective is that it doesn't matter actually for Talos, right? So you can have both bare metal and both VM handled in exactly the same way. It was like, again, yet another thing that I don't have to worry about when I think about like, what should I do under the OS? So what should be my hardware or VM or whatever? Again, my constraint was time. I don't want to spend time on doing things I don't want to concentrate on. I want to just be able to do what I want to do, right? If I want to learn Kubernetes, then I want to do that. And even going back to our teams, yeah, developers, they cannot comprehend everything. So that's why we build platforms. And, you know, the good way of building platform is to find a simple interface and then abstract away the stuff, the complex stuff under the hood, right? And there is this famous quote attributed to Albert Einstein that everything should be made as simple as possible, but not simpler. Actually, it comes from some lecture and it's more complex, but the point is that you shouldn't make oversimplifications, but you should concentrate and find this layer which you want to abstract away, right? So in this case, I'm talking about platforms. There is another book, Team Topologies. It was maybe more than 5 years ago. It was written, and it provides you 4 basic team types. Who knows the team topologies here? Okay, a bit fewer people than Phoenix project. So I will quickly summarize like the 4 teams. There is stream-aligned team. You may think about this normal developers who do some product or maybe internal stuff, but normal Scrum team, let's say, right, or whatever. Enabling team is like a special unit that helps and enables others to do some stuff quickly. Like if there is a team who knows Kubernetes architecture and there is a stream-aligned team that wants to onboard on Kubernetes, they have to help them, right? And there is complicated subsystem team. You don't want to have many of them. If you have some kind of a secret sauce in your domain, then this is the team that wants to be enclosed. And at the end, there is this platform team. And I do believe that this book is not about the 4 team types, but rather 3 interactions, and also putting this in the context of time. So it's not simple to say, okay, you are platform team, you are stream-aligned team, period. You also have to decide how to interact. And obviously, from the platform perspective, the best way is to do this as a service, like software as a service, platform as a service, because this gives you this AWS-like idea from a few years ago when Jeff Bezos told them, the teams, that they have to be enclosed within the 2 pizza rule and also with the API. So if Nothing should be done outside of an API. Everything should be enclosed within an API. And here the platform is the same. Like we saw the inverse pyramid, maybe more like a double pyramid on top of each other, where you have to provide the unified interfaces so that they are extensible for other teams, for other people who want to just use the capabilities of underlying platform and expand them, extend them as much as possible. And here, the different interaction modes also mean that we have to collaborate sometime and facilitate. So in this case, doing a good platform is not necessarily only about making a good API for your platform and doing a good abstraction, but also to make sure that you interact well with your organization. Obviously, when I made myself my Talos Linux, I didn't have to negotiate or collaborate with myself, but it made me think about how to approach this in our jobs. Does it have to be quick and dirty like it used to be? Because if you approach new technology, you just do some kind of a tech spike and see how it works. But does it have to be quick and dirty? I don't think so. So that's how I found Omni, actually, which solved me yet another problem. The problem I had is that I did this. Someone has their own homelab here? Okay. Oh, okay. So you know what I'm talking about. If you start, you're just going deeper and deeper, and many more like machines, or maybe you want to try this virtual machine, or maybe this, or KubeVirt, maybe this one, and it goes deeper and deeper. So Omni helped me just achieve the well-designed abstraction that enables me to do stuff quick and clean, not quick and dirty. And this is the moment where I will try a live demo. So let's just try this. Okay. Okay. So I plan to use my self-hosted Omni instance, but for those who try to use OIDC with Tailscale, there are some things which don't work still. So I will use the hosted version of Omni, which is software as a service. And there is this cluster that I have that's deployed on Linode, which is Akamai Cloud. As you can see, there are a few machines in Stockholm and Amsterdam. And what Omni does is the single pane of glass for me to look at the state of the cluster. But it's not only that. What I will try to do is to create a new cluster with a Proxmox machine that I have in my home lab. And this is the cluster. And let's try to see if I have to. Yeah, it's a newly set up one. And what we will do today, we will try to make use of the newest Proxmox provider. I'm not sure if you know the infrastructure providers in Omni. Maybe I should start with that. So in order to provision a machine, you can either attach it to the cluster by installing the media that you download here from Omni. So you can download an installation media here. It can be from the cloud, like I use Akamai, or generic image, or ISO, and you can put it on your USB pen drive and then stick into the machine and then boot, and it will be visible here in the cluster. This is one way of doing that. But just 2 weeks ago, I believe, Sidero, they released Proxmox. It's very early stage, but Proxmox infrastructure provider. So what it does is that if you go to the settings, you will see that you can set up this provider. I will just put something here, whatever. There is this key that I will not use, so you don't have to worry about capturing it. And this key you will just provide on a Docker image somewhere in the world. It can be, again, in my home lab, so it's not exposed to external world at all. And you can just use it to provide new machines. And if you go here to machines to clusters, and you create a cluster, you can choose. Yeah, let's try to. Okay, let's try to create a Talos con. I will try. Yeah. Let's see if the UI can handle it. Yeah, it's good. Okay. So what I will try to do is to create a, or maybe let's go here. There is the concept of machine classes, which is important. Well, you can create a machine class from auto-provisioning here, and you can choose a provider, like I did Proxmox, And then you have a few arguments, like normally you would do with setting up Talos. So kernel arguments, some labels, yada yada, and then you provide what you would have in normal cloud, like the profile, machine profile, whatever is in the given cloud, like G2, G4, G8, or whatever. There are different kinds of machines depending on the number of cores and sockets. So I already created a few existing classes. So there is this Proxmox homelab 2 with, I believe, 2 CPUs and 2 gigs of RAM. And what we will try to do is let's create a cluster. And because our time is good, maybe we'll see it live. It will be great, right? If it works on live demo. So let's name the cluster TalosCon. Let's try to switch to machine class here. Let's choose 4 gig, let's say, 1 control plane. Let's not be, yeah, and maybe we'll, scheduling, I should have, okay, so we will not allow scheduling. We'll just provide an empty control plane, which then we will be able to extend. But there is a config patch that you can apply to allow scheduling on your Talos nodes in order to schedule actual workloads. Let's skip it for now. Okay, so there is this cluster that we will create. I'm just looking if everything is fine. There is a network error, which worries me a bit, but let's see. Oh yeah, it will apply this automatically. I didn't know that. I always copied it, so today I learned. Okay, so there is this UI that you see that is uploading an ISO on my Proxmox, and let's see if it's really doing that right now. Yeah, it is. On the bottom, oh, yeah, this is something that you can see that a machine is being created. I will also zoom in a bit. It's live, so it's as simple as clicking through few buttons. You can also declare a manifest and use it via OmniCTL and create the cluster declaratively. You can make it more GitOps-like. But yeah, you can see machine has already started, and it's being provisioned, and it's waiting to be joined to the Omni cluster. So as simple as that, with a few clicks of button, I am doing the following. So I have my Proxmox that a new virtual machine was automatically created based on the profile that I provided. Then there is an ISO that's being installed on top of this virtual machine. When it's booting up, it joins the new cluster that I created via Omni. And it's, while it's being connected, it reboots itself and installs on the first disk. You can provide some parameters. On the first disk, the OS, I chose like Talos 111, yada yada. I could add some labels and some kernel parameters. What it does, it's just installing it on the disk of my virtual machine, and we can even go here and try to see if it will show up. Yeah, it's normal stuff that you would see. Obviously, you can choose to go with the normal Talos config and kube config that you have for your cluster. Let's try if we can. OmniCTL, we can use this first. So OmniCTL obviously has is the CLI for Omni, and the name is TalosCon. Let's see if it shows something. Yes. So you can use CLI, you can use manifest to declare the cluster, you can use the UI, but it's very simple, right? It abstracts away so many things for me that I otherwise would have to do myself. So if I did this using my first, let's say, approach, I would use some kind of an Ansible or whatever to deploy K3s on top of Ubuntu, or maybe I would have some template that I would have on my Proxmox. But what I will do then is to make sure that Kubernetes works and try to do some kind of a, I don't know, reconciliation loop. Here, because it's an API-based system, it's immutable, it also introduces the concept of reconciliation loop, because it's like Kubernetes-like approach when you just declare the end state that you want to have, and only then have the result. Okay, let's see if there is some kind of a problem, or is it just normal operations. And again, this is the same output of the same logs that are displayed. Okay, this is most likely temporary. But the point is that what I can do, I can also go to my existing cluster, and I can do hybrid cloud as well. Because this is I have a few control plane nodes in Sweden in the cloud, one worker here in Amsterdam, one worker in Stockholm. I can just add another machine from the same machine class, which is here. Yeah. If I just increase the number of nodes here, what will happen is the same process will happen, but for the cluster, the other cluster that I had existed. So this makes making hybrid cloud, your own hybrid cloud, very easy. I didn't imagine 2 years ago when I started experimenting with this, with the first, let's say, set of challenges, that it will be possible so easily. Okay, while it's booting up, we can see that something here should be already present. Oh yeah, it is. So this is the output of the normal Talos output. So you most likely know that. This is the dashboard. Most likely here it's green. Yeah, so everything works fine. Going back to the presentation. Okay. Yeah, so this is my backup for my homelab cluster, which is not necessary, fortunately, because we made it through, live demo. But what I showed you is basically we did a cloud computing and edge computing, right? So, and we made it simple by using Talos and Omni. And it's really important that I had a few discussions already with some of you that there are true applications of edge and edge computing, because it's like one of these hype words, I would say. But using Talos and Linux, for me at least, makes it very, very easy and simple. And you should use the right tools always when it matters. It doesn't mean that DevOps is only about tools. Actually, it's opposite. But it should help you, the tools should help you to achieve this low level, no friction between the dev and ops, abstractions that work, and also building platforms that are built to last for a long time without any problem. And don't try to build everything by yourself. Let others build some abstractions for you. And obviously, I just recommend Talos and Omni because it just works for me. I think it would work for you as well. Thank you.